Right now, at this very moment, something is moving through our solar system that has no business being here. Its name is 3I-Atlas, and it's not from around here. Not from Mars, not from the Kuiper Belt, not even from the farthest edges of our cosmic neighborhood. This thing came from another star system entirely. And 3 days ago, it did something that has scientists at NASA, ESA, and every major observatory on Earth absolutely terrified. It changed direction. Not the slow, predictable drift of a comet caught in the sun's gravity. No, this was deliberate, calculated, and according to the laws of physics we've relied on for centuries, completely impossible. For the first time in human history, the International Asteroid Warning Network, a global coalition designed to protect Earth from extinction-level impacts, has activated its tracking protocols for an object that didn't originate in our solar system. Think about that. This network exists to monitor rocks that could end civilization. It's never, not once, been deployed for an interstellar visitor. Until now. Because 3I-Atlas isn't behaving like a rock, it's behaving like something else entirely. The math doesn't lie. NASA's Jet Propulsion Laboratory has been tracking this object since it first entered our system, feeding its trajectory into the most sophisticated orbital prediction software ever created. Every calculation, every simulation, every model pointed to one inevitable path. And then, as 3I-Atlas disappeared behind the sun in late October, everything changed. When it re-emerged, it wasn't where it was supposed to be, not by a little, by 1.1 million kilometers. That's 3 times the distance between Earth and the Moon. Objects don't just drift that far off course, not naturally. Dr. Avi Loeb, the Harvard astrophysicist who famously proposed that Oumuamua could be artificial, had already assigned 3I-Atlas a score of 4 out of 10 on his scale measuring the likelihood of extraterrestrial technology. Then came the deviation. Now, behind closed doors, that score has been quietly revised upward, and the International Asteroid Warning Network, which monitors threats to our planet, suddenly elevated this object to priority status. Hundreds of telescopes, from Chile to Japan, from Spain to South Africa, all turn their lenses toward the same point in space. It's as if the entire planet is holding its breath, watching something we're not supposed to understand. The first group to notice was a small research collective called Earth Exists. They're not NASA, they're not government-funded, they're just astronomers who refuse to look away. They compared live telescope data with JPL's predictions, and what they found sent shockwaves through the scientific community. The object wasn't just off by a margin of error, it had moved laterally, sideways through space, in a way that violates every principle of orbital mechanics. Comets can speed up or slow down due to outgassing, jets of vapor that act like natural thrusters pushing them forward or backward, but they don't move sideways. That would require an external force so immense it defies comprehension, or an internal one, something generating thrust from within. Even Hale-Bopp, the most powerful comet ever recorded, couldn't achieve what 3I-Atlas just did. And here's where it gets even stranger. NASA had the perfect opportunity to see this thing up close. In September, their Mars orbiters were positioned directly in its path during the solar flyby. High-resolution cameras, infrared sensors, spectrometers, all pointed at 3I-Atlas as it screamed past the sun at unimaginable speed. Those images should have been released by now. Standard protocol, public data. But they haven't been. Not a single frame. When pressed, NASA officials claim the data is still being analyzed, but insiders are whispering a different story: censorship. Because if those images show something, anything, that contradicts the natural comet explanation, releasing them would change everything. Dr. Loeb mentioned something else in his recent work. He noted that 3I-Atlas exhibited an anti-tail, a jet of material pointing toward the sun instead of away from it. It's extremely rare, but it happens. What doesn't happen is what came next. After the Mars encounter, the tail flipped. Suddenly, it was flowing away from the sun again, as if the object had physically reoriented itself mid-flight. No natural comet has ever reversed its jet direction so cleanly, so precisely. And yet NASA insists this is routine cometary activity. If it's routine, then why is the Asteroid Warning Network involved at all? Why are defense protocols being activated for something that's moving away from Earth, not toward it? By late October, new tracking data confirmed everyone's worst fears. The deviation was accelerating. Over just 19 hours, the positional discrepancy widened by more than 4 arc minutes, equivalent to hundreds of thousands of kilometers. To maintain that kind of drift, the object would need to be moving laterally at nearly 4 kilometers per second. That's more thrust than some of our most advanced deep space probes can produce. Theories exploded across the astronomical community. Solar wind, gravitational perturbations, outgassing asymmetries, but none of them fit. Solar wind doesn't push sideways, gravity doesn't work that way, and outgassing can't sustain that level of precision. The only explanation that fits the data is the one no one wants to say out loud: propulsion. Active, controlled, deliberate propulsion. Meanwhile, the International Asteroid Warning Network announced a training workshop for astronomers on tracking unpredictable cometary behavior. It filled within hours. Behind the scenes, NASA's Planetary Defense Office quietly elevated 3I Atlas to a monitoring tier typically reserved for potentially hazardous asteroids, objects on a collision course with Earth. But 3I Atlas is moving away from us, so why the elevated threat level? Some scientists believe the answer lies in something even more disturbing. They think it's planning another maneuver, and they're right. Just when astronomers thought the anomaly had stabilized, 3I Atlas changed course again. But this time, it wasn't just a deviation, it was a correction. Ground-based observatories across 3 continents detected a secondary deflection, smaller than the first but perfectly aligned with the object's original trajectory, as if it had drifted off course, realized its mistake, and adjusted itself back on target. This wasn't random, it was symmetrical, calculated, exact, the kind of navigational correction a spacecraft executes after an automated system check. The International Asteroid Warning Network issued an internal alert classified as a pattern recognition event, meaning the behavior matched no known natural phenomenon in their entire database. At the same time, the European Space Operations Center released an encrypted update to its member agencies confirming that 3I Atlas had produced measurable acceleration inconsistent with gravitational influence. Translation: the object had fired something. But fired what? When the Very Large Telescope in Chile turned its infrared array toward 3I Atlas, it detected a sudden spike in thermal radiation, a burst lasting exactly 12 minutes, followed by complete cooling, as if a controlled engine had ignited, executed a maneuver, then shut off. Whatever 3I Atlas is, it had just proven beyond any doubt that it could move on its own. The moment that data went public, every space agency on the planet scrambled. NASA doubled its observation schedule. China reactivated its deep space radio arrays, typically reserved for lunar missions, to scan for any electromagnetic signals coming from the object's vector. The European Space Agency deployed emergency protocols from its Planetary Defense Office, a move reserved for imminent impact scenarios. Officially, this was to ensure coordinated observation. Unofficially, it was panic. Scientists at Caltech and the University of Tokyo began comparing the acceleration signature to known propulsion systems: chemical rockets, ion drives, nuclear thermal engines. Nothing matched, but one thing came close. The heat curve resembled something called magnetohydrodynamic acceleration, a theoretical propulsion method where charged plasma is guided by electromagnetic fields. It's the same technology humanity has only begun to theorize for interstellar travel, and whatever 3I Atlas is, it's using it right now. Then something even stranger happened. The object's rotation rate, which had been stable for weeks, began to fluctuate. But not randomly. The pattern repeated every 247 seconds, precise to the millisecond. At first, astronomers assumed it was tumbling, a natural wobble caused by uneven mass distribution. But the harmonics were too clean, too deliberate. It wasn't tumbling, it was pulsing, and some scientists began to wonder if it was communicating. The International Asteroid Warning Network expanded its mission scope overnight. What had begun as a scientific collaboration transformed into something resembling a global defense task force. And then analysts noticed something that made their blood run cold. The object's new trajectory wasn't pointing toward interstellar space, it was heading toward the outer planets. Specifically, its adjusted path intersected with Jupiter's orbital plane. Within months, 3I/ATLS would pass dangerously close to the gas giant, skimming through its magnetosphere, a region capable of generating unimaginable energy. If this was coincidence, it was the most statistically improbable coincidence in astronomical history. But if it wasn't, then the object was executing a gravity assist, the same maneuver spacecraft use to slingshot around planets, gaining speed and altering direction. That realization triggered what NASA calls Level 3 contingency. It meant the object's movement was active, intentional, and increasingly unpredictable. And then, something even more unsettling began to happen. Observatories around the world started reporting radio interference, not the usual background noise of the cosmos, but something structured, repeating, and every single pulse synchronized perfectly with 3I/ATLS's 247-second rotational period. It was as if the object was broadcasting a signal, and Earth's instruments were beginning to resonate with it. The planet itself was tuning into whatever frequency this thing was transmitting. Then, without warning, every observatory tracking 3I/ATLS went dark. In less than 10 minutes, telemetry feeds from Hawaii, Chile, Italy, and South Africa simultaneously froze. NASA's Deep Space Network lost contact. China's radio arrays reported total silence across multiple frequencies. For 47 minutes, the entire global tracking network was blind. When the data streams finally resumed, they all showed the same thing. 3I/ATLS was gone. Not destroyed, not hidden behind a planet or asteroid, simply gone, vanished from every registered coordinate in the solar system. But something remained. A faint echo, a low-frequency hum undetectable to human ears but measurable by sensors. It pulsed across the network once every 247 seconds. The timing was perfect. Each pulse coincided exactly with the object's last known spin period, as if the signal was still out there, bouncing through space, marking its final position. The International Asteroid Warning Network officially classified the event as Interstellar Signal Anomaly 2025-11 and immediately placed it under restricted access. But one detail leaked. During those 47 minutes of blackout, multiple telescopes briefly registered a flash. Faint, directional, and aligned perfectly with Jupiter's orbit. The object hadn't disappeared. It had jumped. In the hours following the blackout, chaos erupted. The International Asteroid Warning Network released no public statement. NASA said nothing. China's Deep Space Network issued a single line before wiping its archives clean. Tracking anomaly terminated. Object unobservable. For an entire week, the world had no idea where 3I/Atlas had gone. Then late one night, the James Webb Space Telescope detected something. A flash of reflected light moving at impossible velocity, streaking just beyond Jupiter's orbit. When analysts ran the numbers, the results defied everything we know about physics. The object hadn't decelerated or drifted. It had performed what scientists call an instantaneous vector relocation. It had changed position faster than light itself could travel, and that is not possible. Not according to Einstein, not according to any law of the universe we understand. For days, scientists tried to rationalize it. Sensor glitch, cosmic interference, equipment malfunction, but then came confirmation. The European Space Agency's Gaia Observatory, orbiting 1.5 million kilometers from Earth, picked up an identical reflection exactly 247 seconds after Webb's detection. The timing was perfect. The signal had jumped, as though the object had duplicated itself across space-time using the same resonant frequency it had been broadcasting for months. Every time that pulse was detected, it didn't fade, it multiplied. It was as if 3I/Atlas had learned how to use gravity itself as a bridge, moving through the fabric of space-time in ways we can barely conceptualize. Then came the most disturbing discovery of all. The International Asteroid Warning Network's command center in Vienna received the priority transmission marked Level Omega, the highest classification in their system. It contained a partial data stream reconstructed from the blackout window, those missing 47 minutes when every observatory went silent. When decrypted, the data wasn't telemetry. It wasn't images. It was binary, a structured transmission embedded inside the network itself, synchronized with 3i/Atlas's pulse sequence. And when decoded, it formed coordinates. But not coordinates for space, coordinates for time. The location matched Jupiter's orbit perfectly, but the timestamp didn't correspond to the present. It pointed forward, exactly 6 years into the future, December 2031. At first, analysts dismissed it as corrupted data, a glitch in the reconstruction process. But as they continued working, something horrifying became clear. The coordinates weren't actually for Jupiter, they were for Earth. A precise trajectory marker, accurate to within kilometers, indicating where 3i/ATA would intersect with our planet's orbital plane in the year 2031. The object hadn't left the solar system, it had set a return point. The file was immediately logged under Asteroid Hazard Level 10 Protocol, the same classification reserved for civilization-ending threats. Every national space agency denied its existence. And yet, 3 months later, amateur astronomers in Australia began picking up faint radio echoes, repeating the same 247-second pulse. But this time, the signal wasn't coming from beyond Jupiter, it was coming from inside the asteroid belt. The signal wasn't drifting away anymore, it was circling back. That's when the International Asteroid Warning Network went dark, permanently. All public data feeds, all observation logs, all tracking information, gone from the internet overnight. The official reason? System restructuring. But insiders tell a different story. They claim a private network of encrypted observatories was established, operating outside any government jurisdiction. Its codename, Project Helios. Their mission, to track whatever 3i/ATA has become, and to prepare for its return. Because maybe this object wasn't just passing through. Maybe it was never trying to escape at all. Maybe it's been mapping our solar system, studying our gravity, our orbits, our resonance. Maybe it's been waiting for something. Alignment, opportunity, the right moment. And now, every 247 seconds, a faint pulse still echoes across the solar system. So weak it blends into the cosmic background radiation, but strong enough to remind us that the story isn't over. The world may have moved on, forgotten about 3i/ATA, dismissed it as another astronomical curiosity, but the universe hasn't forgotten. And somewhere out there, in the darkness between worlds, something is still moving, still pulsing, still counting down. Because when 3i/ATA returns, and every piece of evidence suggests it will, it might not just pass by Earth this time. It might be coming home.